this idea, a rate of change is a very, very important concept in calculus. Basically, half the course we are studying rate of change. So rates of change that's basically what the whole premise is. Calculus AB is really two topics: rate of change and accumulation. All right. So derivatives, the introductory part of the first unit, the first half of the course, is all about rate of change. And for that, you've actually done rate of change in your previous courses, but you found average rate of change. So the average rate of change is the average rate of change is found by taking the quotient, put that in quotation marks, of the slope between 2 points. I know it's not perfectly worded in regards, but this idea of the quotient, I want to just, how do you show your work? Did you show the quotient? I'm going to say that. Did you show the quotient? This quotient is basically the slope between 2 points. Now, the line between 2 points on a graph is known as the secant line. And the slope of the secant, now it's not like trig, equals the average rate of change. So there's basically the average rate of change. We're thinking slope, 2 points. This is also known as a secant line. So if I refer to a secant line, typically that means you have 2 points between those, and you make a line, and of course the slope. So let's also take a quick visual. We have some function y equals f of x. You have a point right here. We'll call it A. You have a point right here. We'll call it B. Therefore, this is f of B. And we'll say that this down right here is f of A. Come back to me. Sorry about that. I'm redrawing the same thing. Sorry about that. Graph did not want to cooperate. It was very much similar to that. All right. You have a graph, you have 2 points. That's the main thing. So we have a graph, a function, we have 2 points. When I connect these 2 points, I have what is known as a line when I connect these 2 points. Now this line is referred to as a secant because it goes through 2 points. The slope of the secant line is referred to as the average rate of change. Now, of course, we do have abbreviation for this, AROC. So if I say I'm gonna move towards using the notation AROC for average rate of change. Does anybody know how to find what is the traditional formula for the slope between 2 points using the function notation. So we're looking at using function notation, a, b, f of b, and f of a. Basically, all right, got it? Yeah. How do you?
Are you talking about y equals mx plus?
Well, I'm just focusing on the slope. So I can also, when I say,
so like rise over run.
Yep, but function notation, perfect, yes. That is the formula I'm looking for. So what is that formula? It is the rise over run formula, but using function notation.
Change over x over change.
Yeah, but we're function notation.
So rise over run equal what? Y over y2 negative 1.
There's no. We're not using y1s. We're not using y2s. We're using function notation.
Maybe like f of b minus f of a divided by b minus a.
And that is it. To Darwin's point, we also think of this as the y2 minus y1 over x1 minus x, or x2 over x1. That is the same formula, Darwin, and I was hoping that the majority of the majority of people would point to that one, our rise over run formula. But something in calculus that's very important though is that we need to shift our work more towards function notation, because what is y1? What is y2? Where? What are we referring to those? We like to talk about function notations, and it'll be, all the formulas we're going to use are going to use a, b, f of a, f of b, but it does mean the same thing. So you are correct for those of you who were thinking y2 minus y1 over x2 minus x1. That's our formula. So if you have a function, so if I give you y equals 5x squared minus 2, and we wanted to find the average, the AROC, we wanted to find the average rate of change between x equals, let's say, -1 and x equals 2. Now, in your homework on Delta Math, that's what's really nice is you'll get to play with the dynamics of the graph and having the point at -1 and having the point at 2 and visually being able to see it. You'll also be asked to find the values. Whoa, that's too close to my real example. Too close. Let's go 3. Or I guess, I think one of the problems in the Delta Math actually has -1 and 2. I'll go -1 and 3. All right. How do I do this?
Plug it in.
Yep. So I would be f of. So start with formula. I find it very important to start with the formula and writing it down with the inputs of the knowns. So A and B. So this would be f of, well, what's B? What is B in this problem?
Are we looking for B? Or?
No, we're given it. So what is it? So when I say use the formula, so what are my points?
-1 and 3.
So f, yeah, so I'm going to do f of 3 minus f of
-1.
All over 3 minus -1. Now, how you evaluate this afterwards is up to you in terms of good math. One of the premises of calculus is good math is good math. Some of you will input it directly into the formula. Some of you will find f of -1. You can find f of -1 on the sides and f of 3 on the sides. and find those values on their own. Now, the premise of this is also, if you want to be strong with this material, is don't use a calculator. All right, we shouldn't be using a calculator just to plug in numbers, especially on here. Unless I specifically say calculator active, try and do nothing with the calculator here. So you can find these values on the side, or if we're doing it by hand and putting it into the formula, I like to use brackets minus brackets, and then of course this would be over 4 like this. Okay, 3 minus negative. So when I do this one, it's 5 times 3 squared minus 2 minus parentheses or brackets 5 times negative 1 squared minus 2. Now, if you don't use the brackets, which are just big parentheses, most likely you'll be off by a negative sign or distributing a negative. So you got to just make sure that when you're subtracting it algebraically wise, what happens is if you don't do it, you know, this minus 2 turns into a plus 2 if you're just trying to do it by hand. So you got to be careful there. That gives me 9 times 5 is 45. Minus 2 is 43. Minus 1 times 5 is 5. Minus 2 is 3. Over 4, which is 40. Over 4, which is 10. So we would say that the average rate of change from negative 1 to 3 is 10. Why? Here's the formula. Formulas are very important for us in calculus. And then I go by. Now, if I wanted to do this, I would have found f of negative 1 was 3, and then this was 43, and then I could just plug in those numbers to replace them as well. So if you feel comfortable doing it on the side and then placing them in and kind of basically going from directly to this step right here, or you would go from here, you'd go from here to here to here. If you wanted to do that, that's also a possibility. Biggest thing is when you plug in and you evaluate, parentheses are very important, and that you get the correct value. Okay. Notation alert. What I mean by this notation alert is that we're doing the same thing, but sometimes we can write the notation slightly different that can help us and pay dividends in our calculus work later on. So we just said that the slope of the secant is equal to f of b minus f of a over b minus a. Okay? This is one way of doing it. Now, we could also, if I had this graph, pick a point A right here, okay? And I can also flip the formula, and I want to note something. We could also write this as f of A minus f of B over A minus B. It's the same thing, okay? So I want to point this out first. Okay, if we do A minus B, typically we didn't do that when we're doing it in practice when we write down our formula. But what I want you to know in terms of algebraically is that you get the same thing, because you get a negative value on top and an opposite, a negative value in the bottom, and the two negatives cancel each other out. So in calculus, oftentimes we don't call this value B, all right? Instead, what we do is we call this A plus H. And in some textbooks, the H is written as a delta X. So in some text. You might see that online and you see all this work with delta x's. I'm not a fan. I like to use h. And it does make more sense maybe with the delta x, but I find it a little bit more confusing. So here's what it means. Instead of calling this value b, we call this b, and we call this a plus h, which means, and here's why it's helpful. Instead of just saying, here's my 2 points, let's focus on 1 point. Let's focus on this a, and we'll look at we'll use another point that is h units away. So for example, in this problem, h was 4. So we started off at -1, and we found the secant with h equals 4. So -1, and then we use 3, which is 4 units away. Now I know that you're like, well, that doesn't seem practical, but trust me, when we get into tomorrow, it is very practical in what we do. Now there is a formula of doing what we're doing that will use the basic secant formula, but oftentimes it doesn't happen. So as a result, we can now say that the slope of the secant would be equal to f of a f of a plus h, okay, f of a plus h minus f of a over a plus h minus a, which gives me f of a plus h minus f of a all over h. So that's the same formula. I wanted to point out that these formulas are all finding the same thing. All 3 of these formulas that you see right here are all finding the same thing. They're all finding the slope of the line, the secant line between point A and point B. Okay. Tangent line. We define that the line tangent at a point touches only the point x equals a when zoomed in And if you're wondering what do it means by zoomed in, a good thing on Google Classroom, like I said, on the assignment Delta Math, you'll see in the practice of zoomed in. Because if I give you this graph right here, okay, and here's the point A right here. So here's A. What I mean by this is that the tangent line would just touch only that point when we zoom in. And I know it's a little bit off, but it's good. It's still close enough. Right there. Boom. But in reality, this line, we keep extending it, of course, would touch another point. But when we zoom into that point on the graph at x equals a, the line only touches that individual point. Okay, that's what a tangent line is. The slope of the tangent line will be our focus for months ahead. So we're going to focus on this slope of the tangent. The tangent is really, 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 really important in calculus. Okay? And it's the focus of our first half of our course, rate of change. The slope of the tangent is approximated by, can be approximated by the slope of the secant for small values of h. And this is why we use the h. And remember what the h means is that the difference between the 2 points. It's the distance between those 2 points on the x-axis. So if we want to approximate, so, for example, we want to find, an example, and we're not, it's maybe i.e., we're not going to do a full example here, i.e., we want to approximate the slope of the tangent to some function y equals f of x at x equals 3. Okay, so we want to approximate the slope of a tangent at x equals 3. Well, if I'm going to approximate it, that means if I find the slope of the secant, I can use first off h equals, let's start with h equals 2. Okay. If I start with h equals 2, then the slope of the secant would be f of 3 plus 2 minus f of 3 over 2. Using the formula of this one, we're using that formula right there, right here. Okay, which is the same thing as f of 5 minus f of 3 all over 2. Now, this value approximates the slope of the tangent. Well, if I want a better estimate, a better approximation, I can use h equals 1, right? And when h equals 1, I would get f of 3 plus 1 minus f of 3 all over 1. And that would give me a better approximation. Even better. And I want to point this out. This is what our calculator and uses h equals 0.001. Your calculator does not know how to do calculus, and basically what it does when you ask your calculator, as we will learn, to find the slope, basically what your calculator does is it uses h equals 0.001. And so it's going to be f of 3 plus 0.001 minus f of 3 all over 0.001. And this right here is typically a close enough value to the slope of the tangent. Now, we will learn how to find the exact value of the slope of the tangent. We will learn how to find the exact slope. We will learn how to not do it by approximating. But in your homework and in your understanding right now, what I need you to understand is this average rate of formula, average rate of change formula, the vocabulary words such as secant, tangent, and this concept, and finally this concept of h, utilizing this letter h in my formula rather than just saying it b, because by using the a plus h in my formula, it tells the person doing the problem exactly how far these 2 points are away from each other. Homework number 8.